Since we'll be talking a lot about software design in this course, it's worth spending a bit of time looking at design from the high level. Why do we need to worry about design instead of just getting down and writing code? What are the goals of good software design? And which goals are most important? What approaches have proven useful in designing good software? And what is the history of the development of such approaches? The next several lecture segments will deal with these issues. This first one, however, introduces a motivating example and a metaphor that we'll return to during the course. And the metaphor in question is something we're going to call the big program. Now, most students in their second or third year of computer science, which is the target group for this course, have written a reasonable amount of code by this time and have graduated from 2 or 3 line Hello World projects to programs of hundreds or even thousands of lines. From this perspective, it's easy to assume that once you know how to code, dealing with larger and larger programs is just a matter of practice. After all, you've gone from 3 lines to hundreds or maybe as much as 1,000 lines. How much harder can it be to deal with a 100,000 line program or even a 1,000,000 line program, especially if you're in a good team and you can split up the work so you each still only write a few thousands of lines? Well, the answer is a lot harder. And large software is not just quantitatively different from small software, it's qualitatively different as well. At a certain size, the challenge of programming takes on a new dimension. The break point, you might say, at which this occurs depends on the individual developer and the particular program. But somewhere between 1,000 lines and 25,000 lines or so, something happens. And that is, you can't keep track of it all at once anymore. There are many other challenges surrounding large code bases, which we'll look at. But this one is primary. When it gets too large to fit into your mind all at once, the game changes. We'll use a lot of concrete examples in this class, and this is a good time for one. Let's spend a moment to consider the difference between a 1,000 line code base, code you'd perhaps consider large but manageable, versus a 1,000,000 line code base, which, by the way, is a middling sized application. The biggest code bases run to 10 million or more lines. So we'll start with 1,000 lines. Given, say, 65 lines a page, well, that's about 16 pages if you printed it all out. And hopefully you're breaking it up into functions correctly and you're not jamming it all from 1,000 lines into a single big main or its equivalent. If you average, say, 20 lines a function, then your 1,000 line program has 50 functions. What about variables? Well, I suppose we'd reasonably expect a new variable each 5 lines. So your program has maybe 200 variables. How about global variables? Well, if you're well brought up, you don't use global variables, but nice programming languages don't even allow them really. But let's say you're a C programmer and maybe a bit of a rule breaker, and you figure 5 global variables in 1,000 lines of code is okay. Anyone can keep track of the modifications to 5 little variables, and it's such a nuisance to pass the same widely used and modified variables as reference parameters all over the place when you could just make them visible and modifiable from everywhere, right? Okay, so how about bugs? Your code doesn't have any bugs. Yeah, it does. Sorry, but even well-tested code is going to have a few. But you've done a really good job of testing. So there are only 2 obscure bugs lurking in your 1,000 lines. Documentation? Well, good code is self-documenting, right? Besides, as they say, if it was hard to write, it should be hard to read. So a new developer taking over your 1,000 line code base is going to have to directly download it into his or her brain from the source code. But one can read and fully comprehend, say, a couple of pages of code an hour, so he or she will spin up on your code with about 1 day's worth of careful reading. So, where are we now then? 1,000 lines is 16 pages, 50 functions, 200 distinct variables, including 5 naughty globals, 2 lurking bugs, and 1 day to read and comprehend. So, we'll come to our first in-lecture question. We'll have a lot of these this course. This one is fairly straightforward. Please make the same calculations for a 1 million line code base? How many pages of printout, separate functions, variables, including globals, lurking bugs, and how many days to read? Now, we can all multiply by 1,000, of course, and that's all I'm really asking you to do here. But the impact is greater when you figure out the numbers for yourself. So think about it for a little bit and pause the lecture until you have those answers, and then we'll return. And returning from that pause, that's going to be 16,000 pages, 50,000 functions, 200,000 distinct variables, and if you scale up, 5,000 globals if you're in the habit of doing that, 2,000 lurking bugs, and 1,000 days to read and comprehend. So it's a lot bigger. Now, the printout alone will kill a small tree. 16,000 pages is a stack of paper over 2 meters tall. And if you're fond of naming your variables X, Y, and Z, you're going to run out of letters pretty fast. Heck, with 200,000 variables, you're going to run out of English words. Even the 50,000 functions are more numerous than almost anyone's speaking vocabulary, so giving them unique names is going to be a bit of a challenge. And those globals that you figured you could keep track of? Well, now there are 5,000 of them. Any chance some obscure corner of code in those million lines will unexpectedly modify one of them? Almost for sure. You know, the globals are worth a brief aside. You're taught never to use them, assuming your language even lets you. And you're told they're a bad thing and will result in surprising bugs. But that's not really a compelling argument at 1,000 lines of code. It's perfectly possible to keep track of 5 global variables in a small code base. But 5,000 of them in a million lines is another matter. Let's do a short thought experiment. Don't break it in a paragraph there. Let's do a short thought experiment. Let's say you're working on a team of 50 people on a big code base. And you decide you need a global variable. So you declare one. And you give it a good name like count. And all is well until 3 months later, when a new team member working on a different floor of the office, you don't even meet them, decides to use a local variable. It's not a global. The newbie is a good citizen. But he calls it count. And he forgets to declare the local. It's a common enough mistake. Now, you know what happens now. Every time his function runs and he modifies count, which he thinks is a local variable, instead your global gets nailed. Now, that's okay, because his function's only executed during the emergency stall recovery procedure for the Dreamliner fly-by-wire embedded system, so it's not going to be a problem too often. Global variables, in effect, have a bullseye on their forehead, saying, please modify me, anyone, even by accident. And that's why globals are forbidden. But the reason only becomes clear in large code bases. Now, returning to our big program, note that it has 2,000 lurking bugs. Now, that's a lot of bugs, and it shows why developers on large code bases spend a lot of energy on testing. We'll revisit this issue in a bit when we discuss testability as a goal of good design. And finally, there's the 1,000 days to read and comprehend the big program. That's 200 working weeks, or about 4 working years. Now, I don't know about you, but I can't remember what I had for breakfast yesterday, let alone remember code that I read 4 years ago or even 4 weeks ago. And this brings us back to the principal point. Even if you spend eternity reading those million lines, you're never going to understand them all at once. At any time, only 2% of them would have been read within the last month and would be fresh enough in memory to comprehend. An experienced developer can be closely familiar with all of, say, a well-ordered 10,000-line code base, either knowing the code that he or she wrote or being reminded quickly of it by a glance at the source. A really good one might get to 25,000 lines, but no one can comprehend and remember all of a million-line code base. Let me close with an analogy I have found useful. Imagine a huge warehouse with many rows of shelving stacked high with a vast collection of different products. Your job is to manage this complex place, periodically reorganize it, find different sets of products within it, and so forth. And the warehouse is in pitch darkness, and you have only a keychain light to find your way around in it. And that's what big software is like. And the keychain light, of course, is your memory. If you had to work in this pitch dark warehouse with only a keychain light, you'd spend quite a lot of thought in organizing it. You'd arrange it so products commonly needed in a set were together, and so you only needed to look at one or two shelves at a time to get your work done, and so forth. That's what good software design does. It reorganizes the most complex systems made by man in such a way that they can be tested, modified, and above all, comprehended in units that are manageable by the human mind.